world has entered an era where two forces, artificial intelligence and the global energy transition, are accelerating faster than our systems can keep up with. AI is reshaping industries, straining power grids, and redefining what nations need to stay competitive. At the same time, clean energy deployment is surging, but it depends on a technology we don't talk about enough: processing power. Semiconductors have quietly become the backbone of everything from data center efficiency to grid optimization to the next generation of electric vehicles. Welcome to Future Energy Insights, brought to you by the World Future Energy Summit. I'm Rob Jones, partner at B2B Connect, and to discuss the future pathways in processing power, I'm joined by Chinmoy Baruah, CEO of ChipX. Thanks for joining us. So let's start with, how is the global semiconductor landscape changing as AI demand surges?
We at ChipX are delivering the most energy efficient chips for the global compute. The whole industry is quite cyclical in how it is shaping currently. As we can see, the geopolitical crisis between the two superpowers, and also at the same time, the way on the one side, US, and on the other side is East Asia. The whole manufacturing is sitting currently in Asia. When it comes to NVIDIA, AMD, or all the global infrastructure providers, they are very highly dependent on Taiwan in today's global stage. And what we have seen right now is that ChipX, we have been able to position quite efficiently both between Asia and also in the Western market, where we are able to produce our chips quite in a much more energy efficient way, plus also at the same time able to deliver both to the Western market and also to the Asian market. I think AI, what we have seen also that the players which are based in the Western market, I think there's 5 layers. The one is the chips, compute, power, infrastructure, and models. I think US and most of the Western nations are currently leading at the most advanced chip and the compute level. But when it comes to power, what we have seen, Asia is still, because there are a lot of renewable sources are still available. And most of the data centers, if you can see the landscape right now, which are in the process of getting built in the Western countries, are mostly, let's say, more or less renewables, but also at the same time more oil and gas power. So it is a quite significantly, where the demand is there, but also at the same time there is an opportunity where the industry we see is a never-ending industry.
With what you're doing, well, let's start with what are you doing, and then what's the challenge that you're trying to crack?
Yeah, so we have currently we have got 4 fundamentals. The one that we are focusing on right now is data centers, and the other one we are focusing on memory processors. So why data centers are significantly important in today's space? If we see the supply chain, there is chips, there is a different forms of electronic cables that goes into the whole infrastructure with data centers, and the source where it comes from, the materials or the components, that matters a lot. And the best example what I want to say is that recently in the last 6 months, what we have seen in the UK and the US, the most of the data centers are getting shut down or getting cyber hacking, or most of the things are happening. And the if we see the primary reason why it is so, it is because a lot of external source entities from outside of the market, where the components are coming from, they are not being tracked properly. I think this is somewhere where the industry and nations are playing a critical role right now, where they are getting to a point where they know that sovereignty of the data center is very important, rather than outsourcing a data center from a third party outside of their own nation. That's one thing. And then ChipX has been very efficiently able to position this, because we whichever country we are going right now, for example Malaysia or US or UK, we are producing inside the country so that we can employ people, we can create jobs, and we can the products get consumed within the country. So that creates self-sufficiency within the country and within the nation. So that's from a data center perspective. And from what we are doing on the memory chips, this is significantly important, because right now, from a national security point of view, US and also in the GCC, what we have seen, they are looking to kind of have an alternative supply chain out of China. And why? Because without the memory chips, you cannot compute data. You cannot process data through the data centers. You need to store the data somewhere. So these memory chips are fundamentally very important. And this is something what we are involved in and what we are able to be deliver so far. And we are also going to be delivering to the whichever nation we go from a sovereignty perspective.
Within that compute power value chain, where do your processors sit? Because obviously you've got the NVIDIAs, the Intels, and we know, what they're doing in terms of their role. But there are so many different types of chip manufacturers within that. So what is it that yours are?
So the supply chain is as it is. So it starts from chip design, then it goes to manufacturing, then it goes to packaging. It's not the normal packaging, but it's a very different kind of packaging, and then it goes to the assembly and testing, and it comes to the end consumer or the buyer. So we are sitting in the both design and manufacturing. What we are not doing is the packaging and the end distributor. This is something what we are not involved. That's the first thing, and I think it is it is quite very significantly also important. Why? Uh, what we have seen right now is that all the Western nations, they are struggling with high-end manufacturing, and this is something what we are bringing to them. And that's the second point. The third point is that NVIDIA or AMD, they are basically not doing manufacturing. They are uh, they are the owners of their compute models. They are the owners of the design. So they still outsource their manufacturing to in Asia. And this is something what we are doing the opposite. We are doing we own our own manufacturing, plus also we design our chips.
And I think your chips are using different materials, aren't they? They're ceramics. So why and what difference does this make?
So first of all, our chips, let's say for example, I take 4 different other competitor chips and 4 units of our chips. So we can do the same amount of work done with a less 50% less energy compared to the other compared to our competitors. Because the materials that we are using are first of all are sustainable, they can be recyclable, and they have got better operational life. Plus also they have got lower latency, what means that faster communication between 2 different chips that are integrated into the PCB board, printed circuit board. So this gives us a unique position to efficiently supply and to maintain that dominance of data sovereignty, transfer, and also security.
Lower heat, I guess, means less cooling.
Yeah, we are less dependent on cooling because our chips can operate at very low temperature, and that gives us a unique position where where our customers, as they have seen, they are very confident that they need to be less dependent on the highly expensive cooling technologies, whether it's liquid cooling or whether it is air gas cooling.
Okay, so how do you start to scale what you're doing then? Because obviously it's it's a big business. There's millions needed every year.
So we have I think last time in July we have partnered with the largest semiconductor company in the world in Taiwan, and we have formed joint partnerships with them as well. So we already have a very intense facility, I would say big facility in Taiwan where we are already manufacturing. But what we intend to do is that as we can see that the crisis is growing each and every day. So we don't want to put all the resources at the moment in Taiwan as we go forward. Recently we have announced in our press release with the Prime Minister of Malaysia that we are going to be building one of the largest chip facility in the whole of ASEAN region in Malaysia. And I think, and to your point, this is a highly capex intensive business, but also with highly capex intensive business, it comes with opportunity because people are more focused right now on opportunity plus also on the premium because they're ready to go for it. It's like they're ready to go for a premium business where even where they have seen security is more important than outsourcing a business from a third country where there is no viability. Whether if if something happens to to their manufacturer, what the whole supply chain is vanished. So that's where we come into play.
And in terms of facilities, you've said Malaysia, Taiwan. What about other parts of the world? Was there a plan to move elsewhere?
We are also in discussion with the German government and we intend to have a facility in Germany as well by in the next 3 to 4 years. But it depends on like all the government practices, then also the subsidies that we are also and also and all the uh, supports that we need from the local municipality, because we are going to because we are going to create a lot of number of jobs over there as well. I think for what we have, the challenge here is not about building a facility. The challenge is the regulatory, because the regulation is something that, and this is something I was speaking in one of the panel yesterday, where I was saying that regulation, innovation cannot sit at the same table. If you want to innovate something, you need to regulate it in such a way that it doesn't impose any restrictions on the scalability. And this is something what delays the discussions and also the ongoing process what we have seen.
Looking at where you see demand coming from, what industries are you working most closely with?
This is a very great question, because what I have seen wherever with whomever I'm speaking right now, they're saying me there's a bubble in the market, and it's a big bubble. For example, how they're playing how they're buying assets, how they're working with all in a very sustained, confined environment of some few selected players. I think for us, our market is like wide open, as and the reason why we are very confident that we are working with today data center players, we're working with renewable energy grid providers, we're working with telecommunication customers. We have also got customers from national security and also aerospace. So I think for us, even today what we have seen in the like all the chips are going into AI, our chips still will have a still demand for the next 10-15 years, because there is a need in the market, and even the market goes down or something happens or some correction happens in the market, we will still be in a very good position, because we are not an AI company focus. We're going after 3-4 different verticals.
Energy efficiency obviously is a really hot topic at the moment. Uh, a lot of R&D is going into how do you make these processors ever more powerful, but lower, a lower power footprint or energy footprint, running cooler. We're seeing a lot of innovations now around cooling. How are you, or what are you doing to try and keep up with that trend? Because what may be energy efficient today may not be energy efficient or considered energy efficient in a few years' time.
So, I mean, the way we see is that, and the way we are working with the other our customers, we have a roadmap like for the next 5 to 10 years. We know like which product in a way when to bring into the market, and we show to our customers, if you work with us, we have this ready, and we have also the next generation ready. So for them to upgrade their product when it goes to when it is integrated into the infrastructure after 1 or 2 years, it will not be a problem. So that's the first thing. Second thing is that the way right now what we if the in the industry, the biggest the maximum limit what we have seen with Nvidia or AMD, so the compute power is a measure of how many transistors we can put inside the chip, or we can say integrate inside the chip. Into this, the limit is 202 billion transistors per. That's the limit so far. What we are doing is that we have kind of been to able a new approach where we have been successfully able to integrate more transistors into the chip at a much more higher surface area level, which eventually helps us to achieve the same compute power at a less, I would say, at a less energy factor compared to our competitors, and this gives us more ability to process more data at a less amount of time.
But can the whole industry keep up with the demand, though, particularly because we're seeing such an exponential rise in AI use? The data center plans that we're seeing are huge. How does your industry keep up with this demand and actually ensure the power demands that start to come through then don't start to impact on the communities around these areas, or people living in energy fragile communities?
I think that's very important, because people are not right now talking about power. One of the other part is the water. because all the data centers that are being announced, so for 10 gigawatt, 50 megawatt, 50 gigawatt, 100 gigawatt, these are like gigantic plans for the next coming like 10, 20 years. And I think energy is going to be the biggest issue here, because even we are talking about nuclear here, I don't see nuclear coming in the next even 10 years, because SMRs are still in the process phase. They're not being deployed. They're like mini SMRs, but not the bigger SMRs. They're still in the process. The other part is that infrastructure. And what I recently, there's CES conference that happened in California, and Microsoft eventually ended up saying that we have got more hardware to deploy than to operate. That means there is no infrastructure. The existing hardware that is in their basement or wherever they have been saying so far, and we keep saying we are, Nvidia or AMD, they are like saying, okay, we have this is in production. Yes, it is in the production, but if we don't have the infrastructure, and also we don't have the power to run those advanced chips, I mean, they will just sit for the next 5 years. So I think that's a serious question that, on the other side, we are focusing on the scalability, let's say scaling factor of some gigawatt hours. But on the other side, we need to be mindful that, if there is no infrastructure to support that compute power, how will you be running the data center?
What about what about the investment side? Because again, ramping up so rapidly requires huge investment. So again, from the industry, where is this money coming from?
I think these investments are mostly coming. These are more like sovereign-backed investments, what we have seen right now in the US, and of course, most of the regional players and the banks, and especially from the GCC, what we have seen, and the commitment from all the AI players, which is about $7 trillion CapEx investment each and every year by 2030. But I think this number, what I have seen recently last week, may be corrected, which is probably they're looking to invest $100 trillion by 2030. But the question still be that, okay, is there a return for the investors? That's still the question. And if we ask a lot of investors in the Wall Street or in London Stock Exchange, they're worried that where is there a return to come back or not. So I think, in whoever is getting involved in this space, especially in the data center, I think there is no quick return. It's not a 2 to 3 year of cycle. It's something that he or she should be very much accept the fact that I'm getting to I'm getting somewhere where I will get involved for the next at least 5 years.
So anybody coming into this really has to have a long time horizon.
Yeah, a long-term vision, and a commitment, and be strategic, like why I'm putting my resources into this data center, what I want in return. So it needs to be very impactful.
Are they?
It's like 50-50 what we have seen so far, because the commitment when it comes to the power still a question mark. And a lot of the localities, especially what I have seen right now in Australia or Europe, they're complaining about this, because there's existing water scarcity. And on the other side, we are talking about to purify these chips that requires hundreds of thousands of gallons of water every day. So this is something not compatible.
Okay, so we're still grappling also with our demand for data, our demand for compute power, but equally, where we haven't got the balance right, maybe, is on the sustainability side, in terms of making sure we're thinking about the impact it has on the communities where these are being built.
Yeah, I think the site selection is something that the data center operators must have a eye on it. Otherwise, if we build a house and after 2 years we came to know that the house we cannot support the house with the water or the necessary utilities, that's like the whole waste of the capital expenditure. And I think that's something the data center operators are not being able to do that. They are mostly going after the hype cycle and the CapEx numbers that has been proposed by all the big players.